Welcome to today's webinar on maximising safety in the workplace, detecting VOCs with the new Ventis Pro5 with PID sensing capability. I'm Peter Shields from Scientific, and we're delighted to have Alex Baburamani from Industrial Scientific Corporation as our special guest speaker. In this session, we will be discussing the foundations of volatile organic compounds, their impact on worker safety, and how VOC detection with the Ventis Pro5 can mitigate these risks. Whether you're an employer or an employee, safety should always be a top priority in the workplace. We hope this webinar will provide you with valuable insights into how measuring VOCs can help maximise safety on your site. Before I hand over to Alex, just a little bit about AirMet Scientific. We're established in 1984, and AirMet specialises in the supply, service, rental and engineering of reliable monitoring solutions to the OH&S and environmental markets in Australia. We operate in all states in Australia with offices in Melbourne, Sydney, Brisbane, Mackay, Adelaide and Perth that all provide sales, service and rental support. AirMet Scientific is ISO 9001 accredited and have NADA accreditations for calibration of gas detectors and flow measurement. We also support the AIOH, FAMANS and RESFIT with sponsorship and professional development awards. And we've been partners with Industrial Scientific for around 20 years. So without further ado, I'll hand over to Alex. Thanks, Alex.
Great, thank you very much. Appreciate very much. Very honoured to be able to present today on an important topic on volatile organic compounds and how to measure those with PID detectors. So welcome to our audience today. Looking forward to a great presentation. As Pete said earlier, feel free to drop your questions. Let's get started. So today's presentation is on volatile organic compounds. We're going to talk a little bit about what they are, where you can find them, why is detecting them so essential, what are the effects. We'll also talk a little bit about the challenges associated with measuring them, what's the technology that's typically used to measure volatile organic compounds. And then we're going to dive into some of the applications associated with them. And these may be related in industries that you're involved in, applications that you're involved in today or could be in the future. So once again, we want to warmly welcome all of our attendees today, and let's get into it. So a little bit about Industrial Scientific. So we've been in business for more than 40 years. We're a publicly listed company, and gas detection is our lifeblood. We're dedicating our careers towards ending workplace fatalities, and that is the noble vision that governs the design of our products and the work that we do. So we were established, as I said, close to 40 years ago, specializing in gas detection and also gas detection software. We've also been in the process of acquiring companies related to environmental monitoring, plume modeling, and so on. So we've had an opportunity to work with AirMet, as Pete mentioned earlier. We've had an opportunity to work with AirMet for more than 20 years. Detecting gas detection, as I said, is where we've specialized in, but being able to use data that comes from gas detection becomes even more critical in being able to prevent future incidents from happening, and also in being able to analyze historical outputs, but also predict before incidents may occur in the future. So Industrial Scientific, in order to be able to fulfill its vision in ending workplace fatalities, have focused on understanding gas detection data, but also how this data applies to our users. Industrial Scientific and AirMet have worked for close to 2 decades. They're an authorised distributor of ours for sales, also an authorised service centre in the locations across Australia. As of the beginning of 22, they are also our master distributor for our channels in Australia, and also are responsible for our iNet fulfilment centre based in Nunawading, Melbourne. So this partnership has allowed us to be closer to our customers across Australia in your time zone, and be able to put the reliable gas detection in the hands of our customers and provide you with the knowledge and the experience to be able to address incidents that occur in workplaces. So, we'll get into our subject today. So, what are volatile organic compounds, or what are VOCs? So, they're involved in the manufacture and use of a multitude of industrial and consumer products that we all use. So, if you think about paints, fuel products, pharmaceuticals, refrigerants, adhesives, they're cleaning products. Volatile organic compounds are present in the manufacture of these products that we take for granted. Now they're volatile because they evaporate at the temperatures that we see on Earth, and they release their molecules into the atmosphere. The lower the boiling point of the chemical, the more readily it's going to be able to evaporate. The word organic comes from the fact that there's carbon atoms, and this covers a wide variety of chemicals, everything from the very simple like ethylene to more complex structures, as some that we'll talk about today. And it affects not only how they're being manufactured, but also how they're being stored. And they've got a very high vapor pressure and a very low water solubility, and this contributes to them being volatile. So in terms of why we think that, why is VOC detection essential, why is it important? It unfortunately has a large impact on our health, and the toxicity is not always understood or monitored. They have their short-term exposure limit, and their time-weighted average can be at the ppm level, parts per million level, and that can be very, very harmful. You're probably aware of some examples in your industry that you've come across. Benzene and the aromatic compounds are a well-known example of volatile organic compounds, and often they are mixtures with xylene and toluene and styrene. And we know that to be a potential carcinogen. Another example would be vinyl chloride, which has been in manufacture for tens of decades, and also identified as a carcinogen. So these are compounds that we see in industry. These are probably the more well-known ones, but obviously there are thousands of examples. So when we look at these compounds, the toxicity occurs at the ppm level, and even though many of these compounds are flammable, the harmful effects occur at the ppm level. So when we think about our industrial workers, the ones that we rely on, they can breathe ppm levels of these volatile organic compounds, and long-term effects can actually happen over the course of time. Sometimes the effects can be felt immediately, but frequently the symptoms don't actually show up immediately, or don't become apparent for months later or years later, unfortunately, and before chronic illness sets in from repeated and extended exposure. And so when we think about exposure, this can happen from inhaling these compounds, skin contact, absorption, and symptoms can vary from irritations in the eyes, skin and nose, respiratory system issues, dizziness, headache, nausea, and obviously compounding from there can be potentially a lot worse from that. When we think about the industries, now this is just a snapshot of the industries. These are many industries that we see across Australia and across the world. Primarily, we see it a lot in the oil and gas industry, and from the use of because of the hydrocarbons involved. But we also see it in petrochemical, which uses those hydrocarbons. But at the same time, there are other industries, and the industries related. In fact, that later in the piece, we're going to talk about two applications in there, which is the emergency response, ERT, and wastewater, and they're linked to many of the industries, either performed in-house or performed by by the municipal. So we're going to talk a little bit more about those applications later in the piece, and look at how VOC detection is achieved, and how the PID detector, which we're talking about today, can achieve that, can detect for that. So the focus that we want to look at next is on specific personas, or specific job responsibilities that we see in the industry, and we understand. So we're going to talk about safety managers, pardon me, as well as occupational hygienists, and it's possible that many of you in the audience today are performing that critical job function, and we value very much for that. So I'm going to talk first about safety managers and then talk a little bit about occupational hygiene and what is a little bit about the job role, what's most critical, and what are the requirements when it comes to VOC measurement or VOC detection. So when we think about the safety manager position, it's responsible for site safety. That can include policy development, can include procuring equipment, the people required, and also critically the investigation of incidents, planning for the corrective actions, and reporting of these policies. And they are responsible to implement the policies to address the challenges that have been identified by occupational hygienists. And companies need to ensure that all the relevant laws and regulations are adhered to, and that they're upheld. So it's an important function. So from the safety manager's perspective, it's critical that they have a device that is easy to deploy and use, is able to output the data that's required, so that significant policies can be implemented and planned for. So when we look at OC hygiene, so that the occupational hygienists, amongst other functions, they support the on-site readiness, safety readiness, including review of are we compliant with what's required. Definitely involved in equipment procurement, definitely involved in implementing corrective actions, and is the go-to, if you like, as the primary safety resource, using scientific methodology to be able to understand exposures and so on. So identifying and analyzing, controlling the stresses that occur. And as we mentioned earlier, with the use of volatile organic compounds, the opportunity for it to be released during use and storage, during manufacture, it is a critical compound that needs to be detected for, over the course of our workers' life, but also the community. So as I said, hygienists need deploy rigorous scientific methodology in being able to evaluate the levels of risk and exposure. And for that to happen, they need access to accurate measurement and exposure levels, and also the historical data. There are a variety of standards associated, and as I said, many of you in the audience are familiar with these, aware of these. These are things that you'd be able to, that you could consistently refer to or deploy, but it can be in the selection and use of protective equipment, respiratory protective equipment, gloves, particulates, and so on. So there are a variety of standards that you work with, and if you feel free to drop a note in the chat if there's particular standards that you refer to when it comes to volatile organic compounds. So we've talked a little bit about what volatile organic compounds are, where they're present, the harmful effects, the long-term harmful effects of volatile organic compounds, who uses them, and which industries that we typically see them in. So with this understanding, what we've seen in industry is that there are a selected number of manufacturers around the world that are able to measure volatile organic compounds using the technology that we're going to talk about today, which is PID, and using a miniaturized version of that detection, because the origins of VOC measurement came from laboratory and scientific analysis. So in that there is limited availability of manufacturers, and because of the technologies involved and the computation that are involved, some of these devices can be on the larger side, and can be bulky to sometimes use for industrial workers that come into contact with these. So what we shared earlier was that these volatile organic compounds have a potential to be present in our environment at any time, not just in a confined space entry. And as with the advent of multiple manufacturers, oftentimes that can be pose some challenges in being able to have the necessary infrastructure to support those different manufacturers, and also being able to train our industrial workers, whether experienced or first day on the job, in being able to understand their current usage. So if there was an opportunity to be able to bring that technology together, there's obviously an advantage for the safety managers and occupational hygiene. So this is some of the challenges that the industry sees, and we're going to dive into what technology we have on offer today. So I promised that this slide is probably as sciencey as we're going to get today, and talk a little bit about what is photoionization detection. So PID, photoionization detector, and you'll probably find it easier to call it PID and VOC. So I'm going to resort to that. So photo meaning light, and ionization being the chemical term of when using light to be able to break it down into the positive and negatively charged particles. So hopefully as simple as it gets. So the main element is that high energy UV lamp, which you can see in the picture over there, and the ionization chamber which that light is being able to be cast through. So the VOC enters that ionization chamber, the light interacts with it, and then breaks them down into the positive and negative charged particles. And so negative goes to positive, positive goes to negative, and based on the relative difference, a current is generated, and that current is what determines the concentration of our VOC. So trying to keep it as straightforward as possible. One thing that you can notice there, which I'm going to talk about now, is there are other technologies associated with measuring PID. I mean, electrochemical sensors have been used, metal oxide sensors have been used, various semiconductors have been tried to use for photoionization, but over the course of the years, being used to measure VOCs. But through the years, in terms of industrial applications, in terms of their response time and so on, PIDs have been many of the more relevant and available detection methods. However, it's not without its drawbacks, and it's always good to talk about that and how that's addressed. So our PID sensor being used in the Ventis Pro is manufactured by Iron Science, an established manufacturer of sensors around the world. And one of the main issues associated with PID is the presence of humidity. Now, humidity can pose a challenge for a couple of reasons. One of them being that it tends to weaken the signal. So you are actually showing a particular reading, but you're actually showing a lot less because of the humidity present, because of the water vapors contact within that chamber. The second thing it can sometimes do is cause false positives. So you can see on the picture there is a membrane. So that's a gas permeable and water impermeable membrane. And the reason, so basically permeate meaning the opportunity to pass through. That's very, very important because it looks to reduce the level of water vapor that you see within the ionization chamber. So the second design feature is that ionization chamber is made a lot smaller as well to minimize the amount of water vapor that can be present. So understanding the advantages of using PID technology does have its drawbacks, but these drawbacks have been looked at and have been addressed within this particular sensors technology. So when we think about volatile organic compound measurement through the PID, what we need obviously is a rapid response time. We want it to be able to detect, because in the application that we're talking about today, and I'm holding a Ventis Pro device here with PID in front of me right now. You will find that it's a device that I can easily wear on my person, and you want to be able to have a very fast response time. You want it to be sensitive to the VOCs present in the atmosphere, and you want it to output a stable signal. and whether that's showing the reading, or also impacts of humidity and so on. So for these reasons, the PID is generally accepted to be the best technique in being able to measure volatile organic compounds. Okay, so whether that application is being used by safety managers or occupational hygienists, there is the opportunity to have a reading, to know the reading across your plant or across your facility or site, and being able to draw the data through the gas detection software that we have is an important step in being able to develop policies and avert these hazards from occurring in the future. So a little bit about the device that we have here. It's an instrument that is the Ventis Pro device that's been with Industrial Scientific for over 7 years. It has the ability to connect to other Ventis Pro devices. It's able to measure 5 gases at once, including the volatile organic compounds, flammability using an ultra low power LEL sensor. When using those 2 sensors is with the relevant battery option, it can measure up to 23 hours of runtime. Compact device using one of the cutting edge technologies when it comes to PID sensors. So that's the Ventis Pro device that made by Industrial Scientific. And some of the other features of the Ventis Pro device, you saw its compact size. It is IP68. It's dust and water resistant. It's a rugged device, easy operation with 2 buttons. Has the opportunity to be able to communicate with other devices, and it also features a series of wireless radios. So depending on relevant approvals in your local areas, it's able to communicate with other instruments, but also through the cloud, and provide location tracking for individuals as well, or lone workers out in the field. Today's webinar is about the Ventis Pro with PID, but we also have the area monitor, which is also made by Industrial Scientific, the Radius BZ1. The Radius BZ1 has the facility to, pardon me, a little bit too fast. The Radius has the facility to be able to communicate with the Ventis Pro. So in the example that we see over here, it's a confined space entry. Whether that involves PID, whether it involves VOC measurement or not, the instruments on screen, the 2 personal monitors, as well as the Radius BZ1, are communicating with each other to be able to provide a local peer-to-peer alarm setup. So there are up to three different devices from Industrial Scientific that's able to measure VOCs, and one of those devices uses the technology that we're talking about today from Iron Science, which is the Ventis Pro. So we talked earlier about the verticals, or the vertical segments that we see VOC measurement in. The main sector is the oil and gas sector, from the processing and refining of crude oil, and crude oil is a complex mixture of hundreds of different VOCs, and they're all toxic at ppm level. The petrochemical industry is another industry, because they refine and process this crude oil, and it's used for the building blocks of a variety of materials that we take for granted. Today, we are going to talk about 2 examples that are related. As I said earlier, the emergency response and water treatment are sometimes in-house operations for a variety of industrial companies, and in some cases it's an outsourced resource, through municipals and other companies out there, both private and government. So the first application that we'll talk about today is VOC in the measurement of emergency response, or HAZMAT. Many hazardous incidents occur involving VOCs, and oftentimes when the HAZMAT response team is sent there to the scene of any incident, there are many unknowns that are involved. So it's critical for first responders to tackle each incident and measure the VOCs that are present. And secondly, we're going to be talking about application in chemical and wastewater treatment. So the VOC has the opportunity to be able to measure, the PID has an opportunity to be able to measure VOCs in solvents, which get used a lot in chemical processes. So firstly, talking about emergency response. So if you think about it's an essential for emergency response teams to have VOC detection available, because in many cases it's not known what is the toxicity or complexity of the hazard that they're looking to address. Many times ERT teams are looking for the source of the leak, and the source of the leak can relate to VOC leakage. So this could relate to traffic accidents, spills, floods, or other natural disasters that occur. So the ER team is always asking, are we entering a dangerous environment? So if you imagine a plant or a facility where there's been a leak or there's been an odor complaint, the emergency response team or the fire department gets called in, and immediate evacuation is being called in. The team has to be able to identify the source of the leak, and having a portable VOC detector and will allow the team to be able to identify the source of the leak and move, be able to cordon off those areas. So it does perform an important function. What's critical to state here is that the PID sensor will detect the presence of a volatile organic compound, but not necessarily which compound that is. And further information will need to be known or made known, regarding the incident that's happened, to know what potential compounds can be released, which makes the role of the safety managers and occupational hygienists even more critical to understand, what were the hazards present before the ERT team was actually called in. So the second application where we see VOC detection is in water treatment facilities. So as I said, it could be in-house water treatment or performed by a third party. In many cases, they're talking about large-scale treatment plants, and many of these chemical facilities work with industrial solvents, and this can often leach into the environment in one way or another. So we're thinking about PCE, which is used in solvent cleaning, MTBE, which is used as a gasoline additive, and these are just some examples of the VOCs that get released into the environment, which makes detection even more critical. So they need to treat these facilities and find that having a competent PID detector allows to identify what VOCs are present, and this can range across from measuring for benzene, toluene, and other compounds that we're able to see here. So typically the PID sensor may be the only way to detect some of these chemicals. So if an unknown chemical gets discarded, it's a practical option to deploy the PID first before things can be understood, before then samples can be taken to analyze further. So it does form a critical function in being able to screen the chemicals that are present in water treatment facilities. So many of your audience are probably familiar with the instruments used by Industrial Scientific through the years, and the instrument that you see on the right is the MX6, a device that's been in operation for more than 20 years, and was the device that we used to measure volatile organic compounds throughout, and still is today. Sometimes we've had questions relating to when to use what sort of device, and they both have their practical applications in terms of when to use which device. When we think about the Ventis Pro instrument, when you want a compact personal monitor to be used to measure 5 gases or up to 5 gases at once, you want to have that connectivity. It is a device being used for personal monitoring. The Ventis Pro provides those advantages, a speedier response time, and one that can be deployed right across your worker fleet. When there are more than 5 gases to measure, so up to 6 gases, and there's certain gases that you want to look into, like chlorine and NO2 and so on, the MX6 becomes the device, the go-to device, and also when you know that benzene is the VOC that you want to be able to measure, there is a faculty within the MX6 that allows you to be able to measure for benzene using a scrubber tube. So they do have their respective advantages, and I talked about the Radius BZ1 area monitor earlier as well. They're part of a strategy. It's not one or the other. It's part of an overall worker safety strategy based on the known hazards that you're aware of, that your team is aware of, that you're looking to address or indeed even investigate, to be able to develop your procedures and policies. So it's using the right tools that's needed for the job. So come close to the conclusion of our presentation today. Just wanted to summarize some of the key areas that we talked about. So when you think about the Ventis Pro with PID, the opportunity exists to understand your worker safety across the plant, knowing that the presence of volatile organic compounds has both an immediate as well as a long-term effect on worker safety, leading to more chronic illnesses. So there is an importance to be able to have more workers within the facility having this detection available with a compact device. You also want to be able to use the technology that allows the fastest response time, sensitive and a stable signal. So the instruments and the sensors that we use are tested in the market, tested in the field, and it comes in the ability to address for factors like humidity, which we addressed earlier. So this is something important to consider when you're deploying your devices out in the field, that you want a reliable signal or reliable concentration to be able to analyze further. It is a device purely by virtue of being able to communicate with each other. So the Ventis Pro devices are able to talk to each other. They're able to share peer-to-peer alarms and so on. So having that available on your ERT teams or any team that gets deployed to an incident allows you to address those issues in the immediate future. And finally, the compact nature, and I've obviously held the device in my hand a couple of times during this webinar. The ability to have that instrument, easy to deploy, easy to wear, and continue about the day's duties is important as well. So there's a variety of positives associated with using the Ventis Pro with PID. It's definitely something that we're hoping to bring to the attention of our audience today. So I've reached the conclusion of our presentation. Love to field some questions, or indeed, the next slide here has got contact details of myself and Peter. Feel free to reach out to the two of us on LinkedIn. So I'll just flick back to the questions page. And hopefully you found today's webinar informative, and we value the experience of the audience that's joined us today.
I've got one here from Will. Alex, are you looking to upgrade or replace the hybrid MX6 anytime soon?
Okay, so that's a great question, Will. So the MX6 has been in our family for over 20 years. It has the functionality of being able to measure 6 gases at once. The instrument will still stay in our family, at least for quite a number of years to come. We are actively looking at our next generation gas detection, which is looking to come out in the next 2 to 3 years. But even with new technology coming out, we keep our current family in the fold, usually for anywhere between 5 to 10 years later. So the MX6 is definitely part of our family in the mid to long-term future. But there are devices being looked at specifically for confined space entry, and we're looking for that to come in probably in the next 2 to 3 years. It's still in the development stage, still establishing voice of customer, trying to understand the uses for such devices, and then develop from there, which we value very much.
And another one from Will, have you got any small wearable benzene PID detector? I think I can.
Okay. So thanks, Will. So the Ventis Pro is the smallest device at the moment. It's less than 200 grams. It does have the ability to measure a few gases at once. We do have sometimes we do get requests to measure as a single gas, but for now the Ventis Pro is the smallest device that we have to measure just to measure VOCs. But well, if you reach out to AirMet and if that is something that is obviously important to your business use, we'd love to hear more from you and hopefully conduct a voice of customer with you to understand the application better, particularly for VOC single gas measurement.
Thanks, Alex. Yeah, we've got another one here from Ting Ting, which is an interesting question. We've used both PID sensors and GCMS to measure the VOCs and found the concentration difference is huge. PID sensor reports like 10 to 20 times higher of the actual VOCs and could be a major issue when designing for VOC removal units. What is your comment on the accuracy of PIDs? I could actually add something in there a little bit. I know you're going to get some. Yeah. There's always going to be probably a difference between a portable PID and a laboratory GCMS when you're going to be getting more specific speciation with the GCMS and more accuracy. I think one of the things with the Iron Science PID that's installed in the Ventis Pro5 is that there's very little issue with humidity on the sensor. It's actually using this Ventis electrode technology, which effectively eliminates the effect of humidity, whereas a lot of PIDs, portable PIDs, are using a relative humidity sensor and then using a you call it like a correction factor, a correction for the humidity, which certainly isn't as accurate as the patented technology that's used in the Ventis Pro5 with the Ventis electrode design. I hope that helps, but yeah, I think we can.
Pete, thank you for that, because that was informative for me as well. The PID, when we think about personal detection, we're actually miniaturizing or microizing the technology into a smaller device. So definitely accuracy is one thing that can get affected, and when you're dealing with larger chromatographs, you've got corrections for temperature and pressure and other areas as well, which get looked at. I'm thinking about GCs that are sometimes used in mud logging and so on, where you've got those sort of corrections applied, and that sometimes can be the difference. When you think about what personal monitoring is used for, it really is to be able to detect the presence of that gas and then be able to address it. So knowing that VOCs, the majority of VOCs have their harmful effects in the ppm level, knowing that there is a source allows us to know that, okay, there is a potential incident occurring, there is a potential hazard to be able to address for whatever reason. It could be a minor leak, it could be an opening in a flange, it could be any one of those things, and then bring in other tools to measure. So PID, strong tool for screening, strong tool for presence detection, knowing that it happens, and even though a lot of these volatile organic compounds are flammable, it's not going to reach that percentage to alter an LEL sensors level. So we do need that quick detection, and that happens to be in a miniaturized format rather than having users carrying large devices out in the field all the time.
Yeah, and I suppose the other factor in that too is that not all VOCs respond the same to a PID. So part of the understanding is what you're actually monitoring, because there's usually a portable PIDs calibrated with isobutylene, and then there's correction factors to adjust that reading for the response to the particular VOC you're monitoring. And if there's a mixture of VOCs, obviously that complicates it even further.
Yeah, and yeah, go ahead, please.
So what gases is the GC testing for? Is it one of the VOCs? Is not one of them? That would account for some discrepancy, maybe. Yeah, so that's a comment from Randall. Michael's asked. Sorry.
That's right, but I was going to say that's a important point. It's not measuring for any one particular VOC. There are response factors within the device, but you can't customize it like you can on the hybrid MX6, and it's measuring general VOC, whether that's benzene or xylene. It can't tell the difference between the two. It just knows that it's a VOC. Yes, a good point.
Michael has asked, what is the percentage measurement of uncertainty?
Okay, so I guess probably more relating to the concentration. I guess it really depends on the application, and possibly, I don't want to jump the gun, Mike may be looking for more of a scientific measurement rather than detection or exposure. But as with all sensors, there is a margin of error.
And we've got another one here from Sharon. Lots of questions. What is the detection limit? Low ppm. Are you looking at anything with the detection limit in ppb?
Okay. Great question, Sharon. At this stage, it's measuring at a 0.1 resolution up to 2000 ppm. At this stage, we don't have the technology to go to ppb. It is something that we have encountered, and we know that is the exposure limits, the exposure levels that is sometimes being asked for in the industry, and that would be part of a future product development. So it's ppm at this level, 0 to 2000 at a 0.1 resolution.
And we've got another one here from Rory, which I might have to look into the detail of this for you, Rory, and get back to you. But he's said when using PID meters in high VOC environments such as sewers, we've had them fail. Readings drop to 0 on multiple occasions, and we've returned them to AirMet. What can cause a PID to fail? So I think for that, Rory, I might try and get some more specific detail on it, because if you've hired or bought PIDs from us and they failed for that reason, I probably need to understand what the issue was. I know, high humidity can affect them, but usually they're pretty reliable. So I'll look into that for you.
It could also be higher concentrations, potentially. I don't know if overrange is one possible reason, but that could happen if it was you're dealing with compounds at a percentage volume rather than ppm present in sewers.
And Terry's asked, why do the why do the MX6 response factors not apply to the Ventis Pro5?
Okay, so really boils down to the programming within there. The MX6 uses a different sensor from a different manufacturer, amongst other things. And the technology was, that software was, the algorithms were designed to be able to work with that sensor in that particular device. So dealing with a different instrument over here, and there are a series of response factors already programmed in, more than 20. There's quite a few, from benzene through to jet fuel, but that's already programmed into the library of the Ventis Pro. So we hope that those are that provides you with a ready tool to be able to detect in the short term.
Okay, that looks to be all the questions, Alex. So I suppose in conclusion, so yeah, thanks everyone for joining us today for today's webinar. Hope you found the information shared valuable and insightful. I'd really like to express my gratitude to our guest speaker, Alex Baburamani from Industrial Scientific, for sharing his expertise on this important topic. If you do have any further questions or would like to learn any more about detecting VOCs with the Ventis Pro5, please feel free to contact us. Thank you, everyone. Thank you, Alex. Have a great day.
Cheers, Pete. Thank you.